This video is about the Pythagorean theorem, and it's found in your text in section 8-2. Since we now know about the AA triangle similarity theorem, right triangles are of special interest to us, because in any right triangle, we get one angle sort of for free, because by definition, a right triangle has a right angle. So we only need one other angle to prove similarity between two right triangles. We've got the right angle, we only need one more. Now here's an interesting picture where I've drawn two right triangles overlapped, and you can see that they share this angle here. So right there, just by seeing that they're both right triangles and they share one angle, we can immediately conclude the blue triangle and the bigger black triangle are similar. Maybe this is the reason for mathematicians' age-old fascination with right triangles, or one of the many reasons. The theorem is named after the ancient Greek mathematician Pythagoras, who lived in about 500 BC. But Mesopotamian, Indian, and Chinese mathematicians all discovered the theorem independently in ancient times. This theorem is somewhat magical and mystical, and mathematicians have loved it for thousands of years. In some cases, different mathematicians in different ancient cultures provided proofs for special cases. So once you find out what the theorem is, see if you can explain this visual proof, which I'll upload to our extension problems folder. Euclid, who's perhaps the most famous ancient geometer, lived in Egypt and wrote in Greek. His famous Elements, kind of a book that he wrote, contains a proof that's quite complicated. It's a proof of the Pythagorean theorem, and in this photograph here, we can read in Arabic a version of Euclid's proof that was preserved. The preservation of ancient Greek ideas was a major contribution of Islamic civilization. Here's a copy of Euclid's proof written in Greek and preserved in the Vatican. This diagram here is well known for being Euclid's somewhat complicated but ingenious proof of the Pythagorean theorem. Okay, so let's cut to the chase. What is the Pythagorean theorem? It's the theorem that says, in any right triangle, the square of the hypotenuse measure is equal to the sum of the square of the legs measure. So remember, the hypotenuse is the side of the triangle that's directly across from the right angle. So C is the measure of the hypotenuse. So C squared equals the sum of the squares of the leg measures. So A squared plus B squared equals C squared, which might be familiar to some of you. Let's do an example problem. We're asked to find the value of x. We're given this right angle here, and we can see that there's a triangle here, but we're not given x, and we're not given the measure of this side here. So this triangle isn't immediately of much use to us. You might remember from another video that I said in any parallelogram, the opposite sides are congruent. So because this is a parallelogram, since all the sides are, since this side is parallel to this side is parallel to that, we know that this missing side equals 7. And in case you're wondering how I might prove that the opposite sides of a parallelogram are always congruent, I'll give you one more clue, and that is that there are triangles here that are congruent. And there are some theorems that could give us a triangle congruency theorem fairly quickly to show that this triangle is congruent to this triangle. Okay. So now that we have the measures of the two legs of this triangle, we know that what we're looking for is the hypotenuse, which is opposite the right angle. That's x in this case. Let's write down the Pythagorean theorem. C squared equals A squared plus B squared. C is the hypotenuse, so x is going to stand in for C. X squared equals, the two legs measure 24 and 7, so 24 squared plus 7 squared. Okay, at this point, you might want to get out your calculator, but it'll be satisfying if you power through the mental math here. 24 squared is 576. 7 squared we know is 49. Doing more mental math, we have x squared equals 625. Beautiful, a perfect square. So taking the square root of both sides of this equation, we have x equals 25. You might be arguing at this point that we forgot to write positive or negative 25, which is true. If we take the square root of both sides of an equation, we do have to specify that we have two answers for x. So this could be or negative 25. But since x is a length in this case, we're going to ignore the negative answer. So we have x equals 25, and that problem is done. You try one. Find the value of x in this triangle. Example 2. A rectangle has a length of 2.4 and a width of 1.8. Find the length of the diagonal. Okay, it looks like we should draw ourselves a diagram here. Rectangle has a length of 2.4 and a width of 1.8. Find the length of the diagonal. Okay, and we know that by definition of a rectangle, we have a right angle here in the corner. So, and we're looking for the length of the diagonal, which is this line here. So let's call that x. And this is somewhat similar now to our last problem. The Pythagorean theorem again says c squared equals a squared plus b squared. And x is what stands for c in this case. So here we have a and b, 2.4 and 1.8. 2.4 squared plus 1.8 squared. If you're familiar with certain special right triangles from a past course, you might be seeing right now that 2.4 is 4 times 0.6, and 1.8 is 3 times 0.6. And you might be remembering right now that there's a triangle with proportions 3, 4, and 5. So just keep that in the back of your mind. But I am going to chug through this calculation as if I were using my calculator. X squared equals 2.4 squared is 5.76. 1.8 squared is 3.24. X squared is exactly 9. So taking the square root of both sides, we have x equals 3, and we can write 3.0 if we want, since we were given one decimal place. And again, we can ignore the negative possible answer to this because we're talking about a length. Now, going back to this idea of a 3, 4, 5 right triangle, 4 times 0.6 lines up with this. 3 times 0.6 lined up with the other leg. Let's see if our answer came out to be 5 times 0.6. Is 5 times 0.6 equal to 30 or 3.0? In fact, yes, it is. So if we had known about a 3, 4, 5 right triangle, we might have been able to solve this simply by using this line of reasoning. But the Pythagorean theorem is a sure bet if you know how to use your calculator correctly, and if you want to use your calculator, it comes out just fine. You try one. A rectangle has a diagonal of 2 and a length of the square root of 3. You're asked to find its width. Okay, one final example. Find the value of x. Now we're given a funny shaped object here, and we're told that we have 2 right angles. So the fact that we have 2 right angles here we can assume that since this side is a length of 10 and this side is the length of 6, we're not looking at a rectangle here. Right? We can't trust our eyes, true, but if we were to draw a rectangle using these 2 right angles, then this side here would have to have a length of 6, not 10. So if we draw a rectangle here inside of this funny shaped quadrilateral, that leaves us with a triangle left over. And since we have we've constructed this line to be perpendicular, we've made ourselves a right triangle. And if this part of the side has a length of 6 units, then this part of the side here must have a length of 4 units. So now we have a triangle with 4 on a leg, 12 on the hypotenuse, and an unknown side. And since what we've made here is a rectangle, we know that x must have the same length as this side here, which is what we're looking for. So let's use this right triangle with the Pythagorean theorem. C squared equals a squared plus b squared. Now remember that C has to be the hypotenuse. So the side across from the right angle is 12. So 12 squared must be, okay, we have one of the legs here, that's 4 squared. The other leg is the one we're missing, so we're going to just leave that as b squared. Or we could have written it as x squared, since that's in the end going to be what's equal to this leg of the triangle. But for now, I'm just going to solve it this way. 12 squared is 144 equals 16 plus b squared. Subtracting 16 from both sides, I'm left with 126 equals b squared. Okay, 128, it should have been, still doesn't look like a perfect square. And in fact, it's not. So b, in this case, is going to be the square root of 128. And just to give you a sneak preview of what's going to happen next, I'm going to show you in the next video how I could simplify this answer so that it would be in a form that's more acceptable. But for now, I'm going to leave it at this and teach you next time around how to get the answer in simplest form. You try this one. Find the value of x. For further practice, see page 292 of your book, numbers 1 to 9 odd, 21 to 27 odd.